But I heard the news that's just getting better and they're trying to reopen and things like that. So it's not working out. It's getting increased worse in Tamil Nadu also. So, oh my God. All false news. Okay. In the US, there is two things. One is reality and politics, correct? So there is some reality and there is also some politics. So I can tell the reality. Yes, the number of cases are went up. They put again lockdown in some places and a lot of restrictions. So they closed all the, especially I live in California. So the schools are not opened yet. And restaurants are still only takeout, no in-room dining. All the fitness places are closed. Personal cares like salons and everything closed. So it's just not usual life. Yeah, it's getting worse. Hopefully, maybe I don't know. For end of this year, things should at least come back to normal. Hopefully. So we are still waiting for participant to join. Maybe so we can give one more minute. We will start. Sure. So any topic that I'm actually trying to have a session tomorrow. Someone asked me a question about semi-supervised learning and also a demo for overfitting. Yes, I will do that. Actually, let me make a note. Okay. Let me send a note and I will do that. Okay. Give me a minute. We already have the demo. I just have to get the source code organized. Give me 1 minute. Underfit, regular fit, overfit. So regular fit and overfit. Yes, so I'm taking care of that. No problem. Yes, of course. All right, let's start now.
Yes, sir.
Okay, so we'll start now.
Okay, sir.
Okay, all right. So I just wanted to first start with because what I noticed actually based on the lot of questions that people asked in the last session. So they need some clarity on how this works in the real world, correct? Example, someone asked me a question, I don't know who that is. So the question they asked me, using the forecasting model, correct? There was some question around customer churn and forecast, something like that actually. Then I was trying to tell something, I don't know whether that person got it or not. So I felt that there is some clarity missing on how does this work in a real world or in an industry. Okay, so what I want to do first focus on that topic. Okay, because even if you look at the faculty development program title itself, it says deep learning using Python. Correct. So I'm not saying back to that. That's definitely good title, but there is more into it. Just Python is not the only thing that what we have. There is more into it. So I just wanted to bring that view to you so that you can understand. Okay. So let's try to understand that, and then we'll go to the other topics. Let's take an example. Okay. So I'm just going to skip this one. We'll revisit this one. Let's take an example. So what is the problem statement? Okay, this is a real problem statement that I'm trying to demonstrate to you. Using artificial intelligence, automate a financial close process. So what is the financial close process? Okay, typically including Anurag group of institution, any business wanted to close their book and declare their incomes, assets, liability, etc. Okay, any business, it is some part legal requirement and some part internal business measurement. How does this business is doing? Okay, how does the business is doing? So that is basically what it is. Okay. Okay, 1 second. I'm trying to tell Durga Prasad to work on the demo. He's texting me something. So the financial close is basically happens in any business. Okay. So what does that means? So you have to declare your incomes, your assets, your liability, and your balance sheet related matters. One is, as I said, it is a legal requirement. So that means if you are a publicly traded company, you have stocks. Customer can buy your stock, and based on how the stock price goes, ups and downs, there will be some benefits for them, or it could be loss for them too. So this financial close process take place in all companies. It's absolutely a mandatory function. So even if you take another group of institution, every month they're paying for the faculty. So that's an expense. I'm just giving an example. At the same time, they're also collecting fee from the students. That's an income. Okay, that's a revenue. So you have one side revenue and you also have an expense. So this you have to declare. That's an accounting rule. So the question is, using artificial intelligence, how do we automate this process? So far what we studied, gender detection. So you give set of data. It could be image or it could be data in an Excel spreadsheet. The machine predicts themselves it's male or female. Okay, so that is gender detection. Facial recognition. So you give a face, the machine understands and tells who's this. This is Dr. Abhilash. Who's this? This is Dr. Ranga. So like this, the machine tells. Okay, so this is what we have seen. But how do I run multiple models? Correct? Not just a one model. I want to run multiple model in a sequence. Okay, in a sequence, and that is basically what this is all about. Okay, so what we have seen, how do I run a decision tree? How do I run a CNN or RNN? So these are the individual models we have seen, but an individual model is just not what we need. So we need a collection of model to run. We need a collection of model to run. So that is basically what we are going to talk about right now. So to solve this problem, using artificial intelligence, automate financial close. So that means, so the entire accounting rule, keep in mind the entire accounting rule currently done by an accountant. In Anurag group of institution, I'm very sure they have a chartered accountant. So those chartered accountant basically look at all the income, revenue, and also they look at all the expenses, and then they create either a balance sheet or an income statement based on what they want to declare. So this process is called financial close. So how do we automate using artificial intelligence? So there are several steps it's going to take place. These steps are accounting rules. Okay, step 1, step 2, step 3, step 4. So these are all financial close process accounting rule. Okay, keep in mind. So this is nothing but your accounting rules. Okay, this is nothing but your accounting rules. So the first one, determine whether the given transaction is valid or not. Let's say you are saying we collected $1,000 from student A, Is this valid? Okay, we spend $200 to buy paper and pencil. Is this expense valid? So that is the first step. Determine whether the given transaction is valid or not. Step number 2, determine whether the given transaction is an intercompany transaction or not. Let's say an example. So there is the intercompany. Anurag group of institution have several other colleges. Let's take one example. Anurag group of institution have another college called Vidya Jyoti. So now you buy and sell something between Vidya Jyoti and Anurag group of institution. So Vidya Jyoti is basically took 100 notebook from the Anurag group of institution. So those 100 notebook basically took place between two companies owned by in a group. So the group owns several colleges. One of the colleges is the Anurag group of institution. So that you cannot declare as a revenue. Okay. So if you get something from there, either Anurag group of institution, you gave 100 notebook. For these 100 notebook, to track inventory, what you do, you go on book, I sold this to Vidya Jyoti, but that's not really a revenue. Okay, so that is called an intercompany transaction. Okay, that's called intercompany transaction. So step 2 is telling in the process, if there is any intercompany transaction that took place, determine. So that is one thing you have to identify. Step 3, if it is an intercompany transaction, then eliminate. Step 4, so eliminate means reverse them out. That's not, you should not declare that in the income or an expense. Okay, that shouldn't be declared as either income or an expense, because that happens between two companies, which is happening at the group level. Okay, step number 4, pair APAR. AP stands for accounts payable and accounts receivable. Every expense there is an income, correct? So there is an accounts receivable, I'm going to get money, then accounts payable, I'm going to spend that money, correct? So that is what technically it means. Pair AP and AR. So the next one is determine if there is any difference between AP and AR. So that has to be balanced out. So that means your accounts payable and accounts receivable must have to match. Okay, must have to match. And last one, if there is any difference between AP and AR, and book the difference. So this is just a setup process I'm trying to walk you through. So what is happening in a real world? In a real world, if you want to automate the accounting rules that is going to happen in a financial accounting, in a financial close, okay? So you have to understand the process. The first step is determine whether the given transaction is valid. Another group of institution auditor, it's going to look at all the incomes, all the expenses. Okay, so what is your income? Income is 1 million. What is your expense? 0.7 million. Is that correct? Yes, that's right. So I'm going to verify. Second, if there is any intercompany, under the Anurag group of institution, there are several colleges. Any transaction that took place between those companies, those colleges, that is should be the report. That should be taken out. If there is an intercompany, reverse them. All right. Pair APAR. All right. Determine if there is any difference between accounts payable and receivable. Next is if such difference, book this one. So now for each of the steps, what I need a model. Okay, for each of the steps, I need a model. So what model I need? So that's what I have here. Okay. So what model I need? That's what I have it here. So there is the first one is identification of the whether the transaction is valid or not. Okay, identify whether the transaction is valid or not. So that is the first step. So for that, what it is, I have to use a model. So what model I'm using? I'm using a simple decision tree. Second, determine whether the given transaction is an intercompany transaction or an external transaction. For that, I'm using artificial neural net. Third one, if there is an intercompany transaction, then eliminate. So that is not a model, that's a simple programming. Okay, no, that is not an AI thing. Step 4, pair APAR, K-means clustering. Step 5, determine if there is any difference between AP and AR transaction, logistic regression. Step 6, if there is any difference between AP and AR, then book the difference. Okay, your accounts payable is $100, account receivable is also $100. It can't be $90. So if there is $100 in accounts payable, then the receivables should be also $100. If there is any difference in this one, book the difference, make it equal. That is when your balance will balance. Otherwise, your balance will be imbalanced actually. Okay. So now you understood. So you took the process. Okay. You took the financial process and map the models. What model we are going to see. Now you can see it is not running a simple a decision tree trying to figure out whether the given image male or female, or determine whether this customer is going to buy the product, yes or no. It is not that. It is not that. So here you see there are several models. It's going to be combined and all of them going to work together. What is the rule? So the rule is nothing but automate the entire financial close process. The goal is what? Declare a balance sheet. Declare a balance sheet. In a balance sheet, what you see assets, you see liability. You see assets, you see liability. So that is what the expected solution. So instead of using an accountant, instead of using a hard-coded accounting rule, instead of using a manual processes, use artificial intelligence. Okay, use artificial intelligence, automate the entire end-to-end accounting process. How could I do this one? So this is how you do. You take the problem, divide them into individual steps or processes. Okay, for each of those one, determine what model you want to use. Okay, determine what model you use. So what we are trying to do, step one will use decision tree. Step two will do artificial neural net. Okay. Step three, no model. Step four, k-means clustering. Step five, logistic regression. Step six, it's not a AI. It is simple programming. So now you see, I'm not running one model. Okay. I'm not running one model. I'm running now four model. Okay. So what does this mean? What does this mean? So that is, you need to understand. So now you see what that means here. So the model one outcome will go to model two as a training data. Okay. The model one outcome will go to model two as a training data. So the model two will be trained based on the outcome of model one. Okay. Understand? The outcome of model one will go to model two as a training data. Why? I don't want to train the model if the transaction data is not valid. Okay. If the transaction data is not valid, then I don't want to send that to model 2. So model 2 is nothing but determine whether the valid transaction is an intercompany or a non an intercompany. So that's a predictive model. It's going to predict, yes, it is an intercompany. No, it is not an intercompany. So what does that mean? I need a valid transaction. So keep in mind, model 2 doesn't do anything until model 1 completes. So the model 1 completion will trigger model 2 training. Understand, correct? So these are all sequential processes. So this is not going to run by one itself. Okay. When you talk about building machine learning application, building machine learning solutions in a scale for production, what it means, this is what it means. Okay. Model 2, which is artificial neural network, will not function anything until model 1 completes. So the moment model 1 creates its outcome, that outcome goes to model 2 as a training data. So now model 2 is trained. Then it needs to be tested. Once it's tested, it's going to produce an outcome. That outcome, okay, model 2 outcome will go to model 3 as a training data. Okay. So what is model 3? In this case, it's a k-means clustering. Model 3 outcome will go to model 4 as a training data. Okay, will go as a training data. The end outcome, okay, the end product is model 4 outcome. Okay, so I hope you understand. In a real world, it is not just running one model and telling, okay, this model predicted, I'm done. Not at all. Okay, not at all. Until model 4 completes, you don't have the actual outcome. You don't have the actual outcome. Okay, model 1 need to complete first so that model 2 get trained. Model 2 completes, then model 3 takes the outcome of model 2 and runs the training process, then it get ready. Then model 3 get tested, that outcome goes to model 4 as a training data, and model 4 produce an outcome, and that outcome is the final outcome. Okay, so now you have to understand, in production, you cannot run this one by one. So it has to follow certain processes, like a workflow, like a workflow. So if it doesn't follow that kind of workflow, then you won't be able to produce at a scale. Okay, you won't be able to produce at a scale. So this is basically how in a real world it works. How do we make this happen? Okay, so model 1 training data, model 1 outcome will go to model 2 as a training data. Model 2 outcome will go to model 3 as a training data. Model 3 outcome will goes to model 4 as a training data. Model 4 outcome is the final outcome that you wanted. Okay, so what does this mean? All this has to perform at a scale. At a scale means, so you can deploy in a production. So if you are deploying in a production, these should continue to work without any intermediate processes. Okay, it should work without any intermediate processes. It should fly. So how do we do this one? Okay, so in order to do this one, what we need to do, typically, I'm not saying it's always like this. It's up to you how comfortable you are. Okay, how comfortable you are. So you have to make each one as a microservices. Okay, so I'm not saying it is absolutely mandatory if you are going to teach this to students. Okay, if you are going to teach the students, so the students has to understand in the real world what is involved. It is not just running a model and trying to predict whether it's a male or female. Running a model, trying to predict the digit, what kind of handwritten digit it is. Okay, is it 2 or 4 or 5? Correct? It is not that. It is not running a simple model and trying to predict whether it's a cat or a dog. Correct? So those are all definitely simple examples. Yes, we do need to teach students, but student also need to understand how does the model one outcome goes to another model as an in training data, so that the model get trained. If you noticed here, model 2 won't do anything until model 1 completes. Model 3 won't do anything until model 2 completes. Correct? So this is how it works. In order to make this happen, students should also need to learn how to write microservices. Okay, because these are all you have to, that if you want to scale for a production, okay, if you want to scale for a production, then these need to be done properly. So what exactly it means? Instead of just focusing so much only in Python, also teach microservices. Okay, how do you write microservices? You can use Python for that too. So what we have done, each of this one, training process, testing process, outcome process, all kind of written as a microservices. Okay, so what is microservices? We'll revisit the topic. We'll talk about it. Okay, so we identified all the required model. Second, once we identified the model dependency, which model is dependent on what? Model 2 dependent on model 1 outcome. Model 3 dependent on model 2 outcome. Model 4 is dependent on model 3 outcome. Like this, you have a dependency. So based on the dependency, you can come up with what are the microservices you want to write. So the reason we are going for the microservices, it is an independent autonomous function. Okay, it is not a block of code. Okay, each model will have its training service, test service, outcome service, each model. So each model will have 3 microservices. Okay, each model will 3 microservices. You call those microservices. For example, when you're ready to run model 2, the first step is call the model 1 outcome microservice, which will return back a set of data in the form of a file or in a structure or in it could be anything. Correct? Like it's going to come there. So like this, you have to write microservices. So what I'm trying to say, so if you are putting a curriculum together, if you are trying to teach the students, so I would strongly encourage, I can share you, correct, some of the work that I'm doing right now, correct? So it's a very heavily written microservices, okay? Very heavily written microservices. So the students should also know how to create microservices on a cloud infrastructure. Okay, the one that I'm currently working on, it's fully written on cloud. Okay, fully written on cloud. So these microservices runs on a cloud, you call them as needed. All right, so that is one point to make it. understand. So I'm sure you already heard about this terminology: service-oriented architecture, web services, microservices. Okay, so I'm not going to focus too much on the service-oriented architecture, web services, etc. I'm going to assume either you know or you may have to spend some time to understand. So what is microservices? It's a independent autonomous code. Okay, so independent autonomous code. Each block works by itself. It is not dependent on. So traditionally what we teach for students, how to write a C program, how to write either Java program or a Python program. But that is a block of code. Okay, it has a, like, so many different functions built in. Okay, so for example, I'm writing a simple application. So the simple application takes an input from the user and takes the arithmetic operation and performs the arithmetic operation. Okay, it could be addition, it could be multiplication, it could be division, etc. So this is basically, I can write in two ways. I can write as a one single program. Okay, for example, so if you are writing, okay, so what we are trying to do, a simple arithmetic program, correct? So I wanted to write a simple, okay, one second, a simple program where we can perform arithmetic operation. Okay, where we can perform an arithmetic operations. Okay, you can write in any language. Okay, come on, one second. You can write in any language. Okay, one second. Okay, so if you're writing, for example, okay, if you're writing in C, so I can write in two ways. Okay, I can add get input. Okay, I'm just putting here get input. Then I'm going to say add, addition, multiplication, deletion, etc. Correct? So this is a one block of code. Okay, so this is one set of code I can write. So this is what we teach student. Okay, if you go to the student's perspective right now, so we put everything, get input. Okay, get input, then addition, then multiplication, then division. Okay, then division. So this is basically one way of writing program. So here what it is, okay, here what it is. So we have everything under one single function. Okay, so this is means, so this is basically what we have traditionally we do. So this is one function has everything. Okay, one function has everything. So this is one way to write. The other way I can write, okay, other way I can write. So this is also, I'm sure you may have taught to student. So what it is, so this is basically, I can write this one. There's a get input. Okay, I can write a function called get input. So that could be one function. Okay, get input. So that could be one function. Second, add could be another function. Okay, third could be multiplication. That could be another function. Next is division. Okay, that's another function. Then you have the individual code block. Okay, add function. Okay, so that is here. Okay, mod function. So that is here. So this is basically another way to write. Okay, so then the division. Okay, so this could be another way to write. So this is the second option. So the third option, okay, this is one way to write. Okay, so these are all traditional way of writing. Okay, I want to make each function separately. Okay, I want to make each function separately. So what does that mean? So I will have, okay, separate functions by itself. Okay, not dependent on this one. Okay, so this means each one will have its own function. Okay, each one will have its own function. So this is one block of code. This is another block of code. Okay, this is mod. Okay, multiplication. Okay, this is multiplication. Next is division. So you see this one, there are several ways to write. Okay, there are several ways to write. So this is individual autonomous functions. Okay, this is individual autonomous function. So these functions here, it's dependent. Even though it is basically like, declared outside, but it depends on the main function. So here it's an independent function. So these are all kind of, you can call them microservices. Addition, one function. Deletion, one function. Division, one function. It's not dependent on other functions. It works by itself. Okay, it works by itself. So that is the concept behind what is microservices. There's more into it. So this may not be the thing that we want to focus, but I'm trying to tell you from the student perspective. So the student also wanted to know what is microservices. Okay, what is microservices? So that is something that quite quite complicated, and it is also heavily used in the field of artificial intelligence. When you're trying to implement artificial intelligence, so these functions are very heavily used, as I explained. So when you have things like this, okay, I have problem one, model one, problem two, model two, problem three, model three, problem four, model four. So since it all comes in one process, the models are dependent on each other. Okay, models are dependent on each other. When you have such dependency, you have to build independent functions. You have to build independent functions. So these independent functions basically allows you to perform without anything, with any dependency. You are not dependent on this one. So model 2 can call model 1 outcome, okay, etc. So this is basically one way to implement microservices to achieve what we want to achieve. Okay, so the um, uh, from your side, what is the key takeaway in your curriculum, or when you try to teach the students? Also spend some time on make students aware writing microservices. Okay, also tell students in a real world, it is not only one model to run. There is a collection of models to be run, and there is a model dependency. Because there is a model dependency. All right. So one is, how do we deploy this one? Correct. Like I said, the idea trying to understand when you have such a dependency. Okay, when you have such a dependency, how do you deploy this one? How do you scale this one? How do you run this one? Correct. So one other thing is we have to write this as a microservices. That's point one. Point two, so this also we kind of touched in the beginning. Okay, what we touched about it. So there are other technology also goes along with this. Okay, and these are all very critical technologies. So this is also something really important. So why I bring to you, okay, in your curriculum, when you're trying to teach the students, make sure you touch these points. Okay, you touch these points. So what is Kubeflow? What is Kubernetes? What is Docker? So what does Kubeflow does? You see the entire workflow here, train model, test model, etc., etc. You can automate the entire workflow. Okay, in a real world, you have several models running either in parallel or in sequence. It depends on how you set up. So if we have, let's say 100 model, okay, let's say you have 100 model to run. So this 100 model will need to be, okay, all dependent on each other. So that means model 2 needs an input from model 1, which is the training data. So how do you automate this whole process like a workflow? And that is what Kubeflow does. So Kubeflow automates the entire workflow when you have model dependency. When you have model dependency, if you're running just one model, none of this is required. Okay? Keep in mind, if you're just running only one model, like what we talked in the class, so the model that I'm running, gender detection, okay? So run a predictive model, predict whether the given image or a data is male or female, okay? For that, you don't need any of these tools. You don't need microservices, okay? You don't need microservices. But in a real world, correct? Even for simple customer churn, you will implement three or four models, correct? Okay, so 3 or 4 models. So in that case, what you need tools like Kubeflow. So what Kubeflow does, when you have several models, the entire workflow of that model, okay, all the models will be automated using Kubeflow, using Kubeflow. So Kubeflow allows you to automate the workflow, such as training data, test data, model outcome, etc. So this whole process will be automated when you have multiple model which works which dependent on each other, okay, which is dependent on each other. So that is basically one thing you need to know. Second is Kubernetes. So what is Kubernetes? Okay, it is a orchestration. So when you have multiple models, okay, when you're building this one actually, let's assume, okay, in a real world, like I said, there could be several sets like this, okay? There could be several sets, like, so what I'm saying, so what we looked at, one set of model. Let's say I have several sets of model like this, okay? There is one set for finance at close. There's another set of model for cash flow. There's another set of model for like creating income statement. Okay. So now I have 3 sets of model, and these 3 sets of model has to run in a way so that I can quickly move from development to quality to production. So that is basically an orchestration. Okay, you are orchestrating the model creation process. So what it is, when you have multiple models, if you wanted to move the model from one infrastructure to another infrastructure or one system to another system, so you have to basically put them in a container. It's, you could imagine like this. Okay, so if you want to move, okay, let's say you want to vacate your house. Okay, so let's say you want to vacate your house in the same apartment where you are living right now. You are in floor 1. You want to go to floor 3. Okay, so you have moved each of those items by yourself in hand. So that is basically one way to move from your apartment to your old apartment to new apartment. Like if you take one by one and put it in the other apartment, that is one way to do. The second way to do, you put all in one bag. Okay, I'm going to package everything. I'm going to just move the suitcase. So that is what this Kubernetes. Okay, so when you have multiple model to run, if you wanted to have a runtime container like a bag. Okay, as I said, I'm in an apartment. I'm in floor 1. I want to go to floor 3. How do I move all my stuff? Option A, you can take individual products, okay, individual items, and move from apartment 1 to apartment 3, level 1 to level 3. Individual item, that's going to take heck of a time, and it is going to frustrate you. Okay, I don't want to do this one. Instead, I'm going to buy a big box and put everything and move at one shot. So that is much easier instead of moving one by one. So the process of putting all of them together and move from one infrastructure or one environment to another environment is what Kubernetes. So the box that I'm referring, that's the Docker. Okay, that's the Docker. It's a container. It holds everything. Okay, that's the container. It holds everything. So Kubernetes, it moves them point A to B. Okay, point A to B. So absolutely critical. Absolutely critical. Without this, there is no way you can build a production scale solutions. Okay, like I said, for learning, you don't need this. Okay, for learning purpose, you don't need this. But if you are trying to teach either a BTech or an academic program where it's going to be offered in a multiple semester, these need to be thought well. Okay, these need to be thought well, because this is how you build applications. This is how you build application. Point 1, Kubeflow is nothing but an automation of model training, model testing, model analysis, model validation, when you have multiple model and each model dependent on others. Okay, in that case, if you want to automate the end-to-end workflow, then use Kubeflow. Kubernetes, it is like a carrier orchestration, correct? It takes the models and moves into another container, another environment or runtime. Okay, another environment or a runtime. So that is kind of a transportation. Okay, a transportation tool which moves from one infrastructure to another infrastructure or one environment to another environment. In order to move that, I need a container, and that container is what? Docker. Okay, as I said, we can go any level, above and below, but I think you get an idea. In a real world, you don't just build one model. Okay, in a real world, you don't just build one model. You will build several models like this. Okay, you will have decision tree, an artificial neural network, k-means clustering, logistic regression. All must have to work together. All must have to work together. So in this case, the model 1 decision tree, outcome of model 1 will go to model 2, which is artificial neural network. So model 2 will be trained based on the model 1 outcome. Model 3, k-means clustering. So the k-means clustering will be trained based on model 2, which is artificial neural net, that outcome. Like this, it goes on and on. And this is called model dependency. This is called model dependency. To automate this entire process, when you have a real solution, correct? You cannot run this manually, and you can't simply use Excel spreadsheet and etc. So you need a tool, and that is a tool, Kubeflow. When you want to take the whole thing and move from development to quality or quality into something else, that is one option. Or you want to build everything in Windows. I want to move this into Linux or in a Unix. So in that case, I need a carrier which carries from Windows to Unix. Okay, all my developments are going to take place on Windows, but my production is going to be on Unix or a Linux. Correct? In that case, I have to move them from Windows into Linux or a Unix. For that, I need a tool, and that tool is basically Kubernetes. To put all the model in one bucket and move. You can't move each one by separately because these are all dependent on each other. Okay, if one model fails, the whole thing will fail. Okay, one model fails. Let's say my model 4, which is k-means clustering. Okay, if model 3 k-means clustering, if that fails, the whole process will fail. So for that, I need a container which put everything, and that's the Docker. Okay, and how do you implement all the things? Okay, programmatically, you could implement all the things using microservices. All right. So one last point, then we'll move on. In the real world, okay, in the real world, what are the dependent technologies that we will be using? Okay, what are all the technologies we will be using? I'm not saying it's always you have to have an Internet of Things. When I say Internet of Things, don't think it's big, like, animal. So it is not that actually. So even for your Apple Watch, Fitbits, any health monitoring tool, fitness monitoring, fitness monitoring tool, lifestyle monitoring tool. So these are all part of industrial IoT. Okay? It is basically used at many places. Okay. So for example, Apple Watch. So people that wearing Apple Watch, they could be living in California, they could be living in all 52 states, or they could be living in abroad. Correct? We don't know. Correct? We don't know who they are and where they are living. So in that case, how do you connect and read all this data? And that's what IoT does. Okay, that's what IoT does. So if you put this in an industry scale, it's an industrial IoT. Okay, so that's an optional. You don't have to have that kind of technology, but definitely in some use cases or most use cases, if you're dealing with health, if you're dealing with oil and gas, if you're dealing with energy, if you're dealing with consumer, so you have an option to interface with this kind of technologies, IoT technologies. Otherwise, it's optional. The second, the student must have to understand the role of big data. Okay, role of big data. How does that comes into picture? So definitely part of your curriculum, part of your curriculum. So this is an interdisciplinary study. Okay, this is an interdisciplinary study. So part of your curriculum, you also put student to learn big data processing. Okay, not just only Hadoop, understand how do you work in this kind of complex infrastructure. Okay, so that is another thing. The next mandatory skill is computing skill. The students should also need to understand how do you write complex programs such as microservices or working with the GPU. Okay, so those are all computing. Okay, those are all computing. Okay, computing means don't think just I'm going to write Python program. Okay, architecturally there are so many things students need to learn. Architecturally there are so many things students need to learn. So one of them is microservices. One of them is the microservices. The student also need to learn microservices. That's a mandatory skill. The second is the artificial intelligence engine. So that is when you have Python, the machine learning library, Qflow, etc. Those things will come. Okay, that is mandatory. The next is data visualization. How do you expose this data, the model outcome, to the user, either in the form of report or in the form of some kind of visual? So for that, there could be an option to learn SAP, Oracle, Microsoft. They have different tools. For example, SAP has a business object. SAP also has analytics cloud. So like this, there are different front-end tools available. So in some form, the student also need to understand. So they may not have been they may not going to become an expert, but they need to know all the different tools that is required. So these are all absolutely mandatory in order for you to build production kit solutions. Okay, under the deployment, you have a Kubernetes and you also have a Dockers. Kubernetes and Dockers. Okay, so if you are trying to teach the students, these will definitely play a role. Okay, all the things will play a role. Okay, so that is why it's called an interdisciplinary study. Artificial intelligence, it is not studying just civil engineering. Okay, I'm going to just focus on different parts of building or construction, etc. So it is not oil and gas. Okay, it is not oil and gas. So I'm just trying to tell you, this is an interdisciplinary study, and that interdisciplinary study basically requires all the moving parts should work together in order to see this one. All right. So what I thought would be helpful and beneficial. Okay, what I thought would be helpful and beneficial for you. So what I'm trying to tell. So I wanted to give this as an assignment. See if we can see if there is a way that we can discuss this in tomorrow class. Okay. So what I'm asking for, determine customers who are going to churn. Okay. And based on the customer churn rate, do a financial forecasting. Example, at a 2% customer rate, the revenue loss is going to be 1 million. At a 4% customer rate, your sales is declining 2 million. Okay. So I'm saying, based on the customer who's going to churn, you are going to lose this much revenue and your sales is going to decline this much. Okay. So this is basically what I wanted to achieve. Using artificial intelligence, determine which customer is going to churn. So based on the customer churn rate, do a financial model. It is a real world problem. Okay. It is a real world problem. So Dr. Ranga has been asking me, give me a real world problem. So this is a real world problem. Sky is the limit, go for it. Okay, sky is the limit, go for it. Okay, you could build this one. You know what is customer churn, no question. And you also know what is a financial forecast. Okay, financial forecast. So how does my financial is going to look in next 3 months, next 4 months, next 6 months? How much money I'm going to get? How much money I'm going to spend? What is the profit I'm going to make? What is the margin I'm going to get? Etc. So these are all part of your financial forecast. Okay. So keep in mind, my question to you, first one is determine whether the customer is going to churn or not. Second, at the churn rate, okay, based on the churn rate, do a financial model. So just for curiosity, do you know how many model you need to implement this one? Okay. If you have a question on the problem statement, ask me. If you think you are clear on the problem statement, tell me at a high level, how many model you think you need. So the first one is determine whether the customer is going to churn or not. Okay. Next, when the customer is going to churn, is it going to be, because when you do financial forecast, the financial forecast is a time series data analysis. You're analyzing data on a timely fashion. Okay. It could be monthly, it could be daily, it could be weekly, or it could be even hours. Okay. So how much revenue I'm losing per hour? Okay. How much revenue I'm losing per hour or per minute? You can go any extent. Okay. You can go any extent, but that's fine. No problem. So my question to you, if we are clear on the problem statement, can anyone tell how many model you think that we need to solve this problem? Okay. So problem one, determine whether the customer is going to churn, when. So based on the churn rate, okay, based on the churn rate, and do a financial model. The financial model could tell revenue losses. The financial model will tell sales declining. The financial model should tell revenue increase, okay, cost reduction, etc. So these are all part of your financials. So what I'm asking you, if you could tell me how many models we need in order to achieve this one, okay? How many models we need in order to achieve this one? Quickly, anybody? Can anyone tell, please? So if you are clear on what I said, okay? If you are clear on what I said, anyone tell how many models we need? All right. So you can use this as an assignment, okay? So I'll talk to Dr. Abhilesh. So this need to be done tomorrow because I really wanted to see how you are coming up with this, okay? How you are coming up with this. So my first, in this assignment, what I'm expecting from you, write a problem statement. Simple problem. You don't have to write too many lines. No need, correct? Even 1 or 2 lines is fine. Second, if it is multiple model involved, select all the models. Third, identify what data you need. Fourth, for each model, determine the future. Okay, for each model, determine the future. In your model engineering, okay, in your model engineering, make sure you capture accuracy, make sure you capture confidence level, make sure you also identify and capture the weightage, the root cause, why something happens. Okay, the root cause, why something happens. Okay, all right. I can see, I'm looking at this one. Someone says 2, someone says 3. So it could be 2 model, it could be 3 model, it could be 4 model. You have to justify that. You have to justify this one. But you are close, you are there, you are following something that what I'm teaching, correct? So that tells me. Okay, so what we need from you tomorrow. So for this particular problem statement, what I have, redefine those problem statements. Okay, that's the first one. Second one, for each of the problem statement that what you're going to redefine, okay, select the appropriate model. Once the model is selected, identify what data you need. Okay, what data you need. You need the data for to predict the customer churn, and you also need the data for to predict the financial models. Okay, to build the financial models. So identify what data you need. Okay, step 1, problem statement. Step 2, model selection. Step 3, data identification or data collection. Step 4, once we have this one, the next one is actually for each model, what is the feature you wanted? Each model, what is the feature you need? So then once you have that one, you also need to say in the model engineering, how do we capture model accuracy? How do we capture model confidence level? And how do we capture the features weightage? Features weightage. So I want you to think about it and complete this assignment. Okay, complete this assignment. So before we meet tomorrow, we will review this one. All right. So the tomorrow session, okay, I wanted to focus on deep learning, how it is applied in real worlds. Okay. So in our tomorrow session, I want to focus on this one. So I'm not going to spend a whole lot of time. At least I'll give you a framework and 1 or 2 live demos. I know some of you are not happy with the way that Durga Prasad's demo went. I can sense, I can see, but that's fine. I'll cover those demos tomorrow so that you can understand how deep learning works and what's the difference between deep learning and machine learning and what are the different terminology that has been used. Okay, what are the different terminology that has been used actually? Okay, so this is basically what it is. Okay, so tomorrow we are going to focus on deep learning, how it is applied in real world applications. Okay, so how it is applied in real world applications. So that's one thing that we wanted to focus on. Okay, one thing that we wanted to focus on. So I will cover this one and also 1 or 2 demos so that you can understand how this works. All right. So with that said, I'm going to move on to today's topic, data engineering. Okay, today's topic is data engineering. So please make sure you understand how the model works in the real world. It's really important. Just simply telling, okay, so take one set of data and trying to predict whether it's a male or female, whether it's a cat or dog, those are all fine for learning perspective. But if you really want to go on a scale so that you can understand how this works in the real world, so these kind of problems are really important. Okay, where you have multiple models, where each model is dependent on another model, and how do you work with these kind of models, and how do you programmatically control this one, etc. It's all important. Okay, it's all important. So spend some time and try to complete your assignment so that I understand where you stand. Okay, so now we are moving on to data engineering. Okay, now we are moving on to data engineering. So what is data engineering? Okay, what is data engineering? All right, let's understand. Okay, so there are several topics involved in this one. So I don't think that I'm able to cover everything on this one. So this includes data collection, data streaming, data integration, data mapping, data conversion, data processing, okay, provisioning, distributed data processing, in-memory data processing, real-time data processing, working with various large data sets, okay, and data quality, okay, and data governance, structured data, unstructured data, machine data, sensor data, image processing, audio processing, data source, data target source systems. So at least at a higher level, you should know what each one means. You may not be able to work, but at least at a higher level, you should know what each one means. Okay, what each one means. It is really important. Okay, it's really, really important for you to understand. Okay, it's really, really important for you to understand. So each of this definitely have its own way of learning. Okay, one way of learning. So when we talk about data engineering, it involves all the things. Okay, so using data engineering, you should know how to collect data, how to stream, okay, streaming data, how to integrate data, mapping, conversion, provisioning, and how do you work with the distributed data processing like Spark. Okay, that's a distributed data processing. In-memory data processing, Alexio, SAP HANA, these are all in-memory data processing. Real time. Okay, as and when things happen, how do we work with that kind of data? Okay, how do we work with that kind of data? For example, correct? So let's say you're trying to build an app. Okay, you're trying to build an app. So you take the example. Okay, in your iPhone, in your iPhone. So when you type a text, so the model automatically tells you or makes a recommendation or gives some kind of a suggestions what text you could use. Okay, what text you could use. So this is basically a real-time data access, correct? Real-time data access. Whatever you type there, okay, whatever you type, it automatically captures and processes and gives you back. That's the real-time data processing. Okay, real-time data processing. So whatever you type, it captures and makes a recommendation, correct? So where are you going, correct? So that is a sentence you want to form. When I type where, it gives you option to choose, right? Instead of you typing. So that means it's a real time. That means it's a real time. So how do you work such things? How do you work such things? Okay, so how do you work with the structured data? How do you work with the unstructured data? How do you work with the machine data? How do you work with the sensor data? Correct. So sensor data. So all matters. Okay, all matters. So in order for you to work artificial intelligently, it plays a significant role, which means data engineering plays a significant role. So these are all topics you must have to understand. These are the topics you must have to understand. All right. So I also want to give you an assignment. Okay, from your point of view. Okay, your point of view. Since we are all, most of us from engineering discipline. Okay, most of us from engineering discipline. So we know what is engineering. Okay, I don't think that we have to go and reinvent this one. If such, and what is data engineering? Okay, you can write your own things. Whatever you feel, correct? Write it. Second, compare this with civil engineer, mechanical engineer, electrical engineer. Okay, because what we have seen so far, okay, any engineering college that you go in India, okay, any engineering college you go to India, so we all have a common branch. Civil, that is common. Mechanical, that is common. Okay, computer science, that is common. And people call information technology, so that is common. But now data engineering, it's an engineering discipline. Okay, it's an engineering discipline. In civil engineer, you study about buildings. Okay, you study about buildings. In mechanical engineer, okay, you study about machineries, correct? Machineries. Computer science, you study about computer software programming. Okay, so like this, you have a different discipline. So now we have data engineering. Now we have data engineering. So we wanted to know what is it. So I wanted to do some kind of a comparative analysis. Okay, a civil engineer does this. A mechanical engineer does this. Okay, like this, what a data engineer could do. And that is what this list. Okay, what a data engineer could do. A data engineer could do all the things which never happened in the past, which never happened in the past. Okay, so we just work on a relational database. We work in a relational database. So we haven't worked at this extent. We haven't worked at this extent. So I want you to spend some time, think about it, and write something about this. Okay, so that we can discuss, we can understand this one. All right, let's move on. So this also we kind of discussed in the last session. So what are the different type of data? I'm not going to repeat this one. So this is basically different types of data that's going to be required. So if you are working in a real AI projects, data could be anything. It could be combination of anything, right? It could be structured data, videos and images, okay? Or it could be unstructured data, image and voices, okay? Or it could be semi-structured data and structured data. It could be any combination, or it could be all, okay? It could be any combination, it could be all. So I'm sure you know each one of us, and we also talked in the class. We don't have to worry about it, okay? So a data engineering works with all this kind of data, okay? A data engineering works with all these kind of data. It is not just only structured data. So what we have seen and what we have taught to the student. So we taught to the student, how do we work with relational database data? Reading data from an Oracle using SQL statement. Reading data from a Microsoft SQL Server using SQL statement. Or like inserting data, okay, updating data, deleting data. So that is what we have learned or seen so far. Now industry went above all these things. okay, above all the things. So industry is working with all these kind of data. So this is one of the quite complex area. So I want you to spend some time answer these two assignments. Okay. So can you give me one use case where we need to use all these different types of data? So I gave you one example. Okay. What I gave you as an example. So conversation based customer engagement. Okay. Conversation based customer engagement. So let me also tell you my current projects. Okay. One of the current projects that I'm currently involved. So this is for healthcare. This is for healthcare. So what they want to do before a patient, okay, before a patient sees the doctor, so they wanted to have a first level of information about the patient to the doctor. So that means, so the patient can go to an online system, okay. It has built-in camera, okay. So the patient can go to in front of the laptop. So when the patient goes in front of the laptop, it automatically asks the relevant question. The system that automatically asks the relevant question. It tells, okay, it collects the demographic information. It asks, why are you here? Okay, I have stomach pain. I want to see the doctor. So these are all fully conversation. These are all fully conversation. Okay. So these are all fully conversation. Okay. So these are all fully conversation. So this conversation, okay, this conversation, how it is done? It is done using facial recognition. So the patient goes in front of the camera. The camera takes the patient, it detects the patient, understand who the patient. It knows, oh, this is John. It takes the John's, it collects the names, and then asks the questions. Okay. So when was your last visit? This was my last visit. What did happen? So this is basically what I'm trying to say. To avoid a patient waiting time, okay, when you go to hospital, it takes a lot of time to collect the information, a lot of time to document everything. Avoid this one. We don't need this one. So when a patient want to see a doctor, there's a first level of information need to be captured. And that first level of information need to be captured using artificial intelligence. In this case, the first step is I'm going to collect the patient demographic information and also patient identification. How do I identify the patient? I'm identifying the patient using facial recognition. So in that case, I need the images and videos. Okay. So how the patient coming in front of the system? So the coming in front of the system happens through a camera. Happens through a camera. Or the patient also can come to the hospital. When they come to the hospital, it collects through the video. Okay, it collects through the video. So that is one thing. Then I need to know the patient first name, last name, etc. Where is that? That's in the structured data. That is in the structured data. So this could be one example that I'm trying to tell you. So what my intent or the project, what I'm working on, every patient who want to see a doctor, before they go to the hospital, before they see the doctor, they wanted to collect first level of information. The first level of information, patient demographic information, okay, their name, date of birth, sex, okay, male or female, and other information. That is one thing. Second, the patient behavioral information, how they are behaving. So that is basically facial recognition, voice recognition, speech recognition. Okay, so for that, I'm using videos, images, voices. So this is one example that I'm giving. Like this, I want you to think through, give me one example, okay, where you can use all of these data sets together. Okay, where you can use all these data sets together. So that is really important. Okay, that's really important. And then second, how to connect, okay, these type of data for a machine learning use case. Okay, how do you connect? When I say connect, so if I'm talking about John, okay, so let's say I collected the patient information. So I'm collecting patient behavioral pattern. The behavioral pattern is nothing but, behavioral pattern is nothing but how the patient is behaving when you ask a question. Okay, when you ask a question, how are they behaving? Are they responding? Okay, no, they're not responding. That means I have to understand speech recognition, how they're speaking. Okay, how they're speaking, and then I have to record that and attach this to patient information. So that is basically what an integration does. Correct? So I'm asking you to find out, write at least one use case where you can use all six of them together. Second, how do you connect these data sets? Okay, how do you connect these data sets is really important. Move on. Okay, all right. So the second one, what I want you to understand, traditional ETL versus modern engineering approach. Okay, so what we have thought for students, we thought for students about, okay, ETL, extract, transform, load. Okay, extract, transform, load. Some cases, okay, depends on what, where this falls under. So you may have thought for some tools, or you may have thought for like, something else. But I'm just saying, now things are changed. Okay, so why things are changed? The traditional ETLs are hard-coded rules, human intelligence driven, hard-coded business rules. So now it's completely self-learning. Okay, it's completely self-learning. So it's basically machine intelligence driven, yeah, self-learning business rules. So that means when there's a change happens, the machine automatically understands. If it's a hard-coded rule, you have to go and change this one. So point, what I'm trying to make you understand, in nowadays, in the AI world, people are not using traditional ETLs. They are going for modern approaches. In the modern approaches, they want to avoid hard coding. They want to use self-learning technique. They want to avoid hard coding. They want to use self-learning technique. Okay, so make sure you understand. Okay, make sure you understand. When we talk about data engineering, instead of using hard-coded business rules in ETLs, how can I use machine learning models while doing data engineering? Okay, doing data engineering, how can I use machine learning models? So that is another important topic for you to consider. Okay, so move on. What we need to understand, what are the processes involved in data engineering? Okay, so when we talk about data engineering, what are the things we will be doing? Okay, so the first thing is identifying the source system from where we want to get the data. So the problem statement, model selection. Once we know what model we are going to implement, then the next step is we have to know what data we need. Then we need to know from where that is coming from. Okay, from where it is coming from. So that is source system. Once we know what's a source system, the second step is within the source system, what source? Okay, for example, data source could be Facebook. Okay, in Facebook, what am I looking for? I'm looking for their postings, or I'm looking for their images, I'm looking for their videos, etc. Okay, so those are all your data sources. Image could be one data source, voice could be one data source. Okay, it could be anything. So those are all different data sources. Okay, different data sources. If you wanted to go little more detail, for example, I need data for my financial forecast. I need data for my financial forecast. Where is the data is coming from? It is coming from SAP. In that case, my source system is SAP. In that case, my source system is SAP. Within SAP, what data I need? I need GL account posting. That is the data source. That is the data source. So in a way, you could say a specific table or a specific column. Okay. In a way, you could say either a specific table or a specific column. So that is basically what a data source. The process to collect the data, it's data collection. Okay. A process to collect the data is the data collection. Next is data preparation. So the data preparation involves, it could be mapping, it could be conversion, or it could be something else. Okay. So what it is, you are preparing the data for the model to use. You are preparing the data for the model to use. So that could be data mapping, data conversion, data integration, etc. So once that is done, data validation. What it means? Do you have the completeness? Is the data complete? Does the data has any accuracy? That the data has any integrity? So can anyone tell what is integrity means? Data integrity means, can anyone tell what is data integrity? I'm sure you know. Can anyone tell what is data integrity based on whatever you know? Can? So what is data integrity? What is data integrity? Can anyone tell, please? Okay, without any anomalies. Can someone tell little bit clear? Can someone tell little bit clear? So correctness. What does it correctness means? So this is basically what is data integrity. when I'm trying to process a specific individual's record. Let's say I wanted to process all the data. Okay, so let's say I want to process payroll for Dr. Oblesh. I want to run Dr. Oblesh payroll. For that, I need to know what is his pay grade. Okay, what is his pay grade? So I'm using artificial intelligence to create his payroll process, to automate the payroll process. I'm taking a specific example. So I'm trying to process the payroll for Dr. Abhilesh. So his pay grade, I need to know. Accidentally, what I did, I queried Dr. Ranga's pay grade I'm using for Dr. Abhilesh. Okay, so this is basically integrity issue. I cannot use somebody else's pay grade to another person. So in this case, I want to know Dr. Oblesh pay grade. When I'm writing a code to get the data, accidentally, I got Dr. Ranga's pay grade and I'm using for Dr. Oblesh. So this is integrity. Okay, that means right data set should goes to right process. Okay? Right data sets goes to right process. Ensuring you are using the right data sets. Okay. So if a data belongs to an individual, that data should be used only for the individual. If a data belongs to a specific process, that should be used only for that process, not for outside of the process. So these are all data validation. These are all data validation. Okay. So making sure that even after performing some operation on the database table, making sure it is updated. Yes, keep in mind, here we are not using any database tables. These are all happens in programmatically. Keep in mind, these are all happens programmatically. Okay, we don't go to database, correct? We don't go to, we read the data. Okay, we read the data and process the data. We read the data and process the data. So I'm just trying to tell you, during your machine learning building process, you will work with all these steps. Okay, you will work with all the steps. You will work with all these steps. So one of the step is the data validation. At least at the minimum, you have to ensure data completeness, data accuracy, data integrity. So I would encourage, spend some time, understand. Let's assume what happened if I don't do the step. Okay, let's assume I'm not doing any data validation. What will happen? What will happen if I'm not doing data validation? What will happen? Can anyone tell, please? If I'm not using data validation, let's say I don't have any process called data validation, then what will happen? Okay, can anyone tell, please? So if we don't have something called data validation, so we have data source, we have data collection, we have data preparation, then I'm moving on to data provisioning. I'm moving on to data provisioning. So if you're not doing data validation, what will happen? Many things. Point one, your model, if it is, even if it predicts accurately, you don't know what's going on. You don't know what is going on. Okay. It is not duplicate. It is not duplicate, correct? We are not duplicating anything. This is not duplicate. So if you don't have a data validation, point one, the model accuracy questionable. Model confidence level questionable. The weightage of something that happens, okay, that is questionable. You don't know what it is. So this is where everything will fail. This is where everything will fail. Then you will start all over again. Then you will start all over again. You will start all over again. So this is basically most critical step. Most critical step. So part of the data engineering, you will be performing data validation. You will be performing data validation. So if you read about Qflow, it also takes care of all the things. Okay, all the things what we have: data source, data collection, preparation, mapping. So you can use Qflow to do all these things. Okay, so Qflow can do this part, but you have to understand what it means first of all. Correct? You have to understand what it means first of all. So all I'm trying to say, data provisioning, it's basically is the key outcome of data engineering. So data engineering by definition, what it says, make data available. Okay, make data available for the model to run. That's what data engineering. A civil engineer, what the civil engineer is doing, creating architectural diagram. So make the architectural diagram for the low level people to work on. Okay, the construction people to work on. The first step is a civil engineer must have to create an architectural diagram. Okay, so that means a civil engineer provides architectural diagram to do anything further. All right. A mechanical engineer makes a machinery which produces many things, correct? So making the machinery available, that's a job of mechanical engineer. A software engineer, okay, what the software engineer does, the software engineer making the software program ready to run. So, okay, see the word making available. Similarly, a data engineer make the data available for the model to run, make the data available for the model to run. So overall, what I'm trying to say, the process that is involved in data engineering, it starts from the source system, data source, data collection, data preparation, mapping, validation, provisioning. So these are all the core process involved in data engineering. Okay, the core process that's involved in data engineering. All right, let's move on. So we understood what are the process involved in data engineering. And one second. So now one of the things that what we talked in the beginning, okay, one of the things that what we beginning, the difference between traditional approach and artificial intelligence approach. In a traditional approach, when you do data engineering, you hard code the business rules. In the modern approach, we don't do that. So we want to use as much as machine learning models. So if you noticed, every company, okay, they all have the word artificial intelligence on their website. Okay, every company, we don't know heck what they're doing. Okay, we don't know what they're doing. Every company has the word artificial intelligence on their website. Why? They all know that's where they're going. Okay, so what does that mean? The number one reason, correct, the software applications. If you look at the software application, there are so much hard coded. Okay, hard code means you don't have to hard code only in program. It could be table driven, or it could be INI file, or it could be something, correct? So there are so much hard coded dependency. So what does that mean? When there's a change in the business side, then you go back and make all such changes. That causes enormous time, enormous money, resource. How do we avoid? That is the artificial intelligence self-learning mechanism. That is the artificial intelligence self-learning mechanism. So this is just an example for you to understand the traditional approach of working with the data using artificial intelligence new approach, right? So what I'm saying, I'm asking you a question here. Does K and N, K nearest neighbor, and K means falls under classification problem or a regression problem or something else? I'm sure you know. I don't need to tell this one. That's just one thing. Okay. So how does a typical data engineering platform looks like? Okay. As I said, it's a combination of all the three. Okay. So when a data engineer, you will be dealing with at all level. Okay. There's an industrial internet of things. That is one area expected to work, and a big data, another area was expected to work, and then AI platform by itself. Okay. So this is basically a way to look at, how does, if you say I'm a data engineer, if you are going out and say a data, you want to say a data engineer, the expectation from industry, you must have to work in all the things. Okay, you must have to work in all the things. When I say all the things, IoT as well as a big data, IoT as well as a big data, and you also need to know how to interface with the AI platform, how to interface with the AI platform. So this is an industry expectation. Okay, this is an industry expectation. So I'm not saying that it is absolutely must, but that's an expectation. Okay, if you're working in IoT, you should know how to connect and read data from a device. What is device? An Apple Watch, that's a device. Yeah, fitness monitoring machine, correct? So you go to a treadmill, you run. So that's basically tracks everything that what you're doing in the treadmill and reports back. So that you should know how to connect and read data from this one. So those are the things falls under industrial IoT. Okay, industrial IoT. And obviously, when I say big data, when you have large amount of data, so we should know how to store, how to process, how to retrieve the data, correct? So we should know read, write, process. So on a large capacity, in a different format. So those are the expectation. So in a real world, this is how you see a data engineer role. He or she should be able to work with devices, sensors, and also able to work with any machine level interface. Next, store and process very large complex data sets. Store and process very large complex data sets. Third, you should know how to interface with an AI platform. Okay, an AI platform. So those are the key area for a data engineer to understand. Okay, all right. So some of the technologies expected to know. Okay, I'm not saying this is the only technology. Some of the technologies. Okay, so what are the technologies you are expected to know on IoT side as well as big data side? I'm sure you all heard about it. I have seen a lot of training institution teaching some of these tools. Like, if you are dealing with the big data, you are expected to work HDFS, Hadoop Distributed File System, Yarn, MapReduce, Spark. Okay, so I'm not going to read through, but this is the kind of technology expected for you to work on. Obviously, cloud plays a very dominant role. So you should also know how to work on a cloud infrastructure. You should also know how to work with a cloud infrastructure. All right. So this is something that I would say you may have to consider. Okay, if your goal is to go and teach this for the students at a scale, the student need to understand all the things. Okay, one second. So the student has to understand how to work with all these different technologies. Okay, so it could be one or two, or it could be combination of many. It's all based on the real world application that you're going to see. Okay, so it is absolutely critical. At least one or two tool the student should know how to work with. Okay, so if you're trying to teach Hadoop, that's not a problem. You can continue to evolve so that the student can understand how to work with Hadoop HDFS file system and able to store and process large volume of data, where it could be file or image and etc. If you are trying to work with an IoT, so they should know how to connect to devices, and they should know how to read a device, and like a Apple Watch, correct? How do we connect and read this one, correct? So for that, there are different technologies. The students should know this one. Okay, so this just tell you what are the different technologies that's involved in order for you to make this work. Okay, in order for it to make this work. All right. So what I was talking about, how do we read data from a cell phone? Okay, I want to connect to a cell phone and read data. And how do I read data from a camera? Okay, so when I say camera, I'm walking into a retail store. The retail store, there's a camera which basically captures whoever coming into this one. So how do we connect such things? And also I want to, if someone is posting something about me, correct? Someone is posting about me, I should get notified. And how do we read this one? So Apache Kafka. Okay, Apache Kafka, it's one of the things. All right. So I think someone asked me a question, the difference between data lake and data warehouse, correct? The difference between data lake and data warehouse. So typically what do you notice actually? So when you read it, when you read a text, a cell phone text, okay, when you read a cell phone text, so you have to store this somewhere, right? Why? In order for me to process further or do something about it. Okay, do something about it. So for that, I am going to use a data lake. Okay, I'm going to use data lake. So when you walk into a store, it captures the camera. The camera captures an image of you. Okay, so where does that stores? So that stores in a data lake. That stores in a data lake. Okay, so this is basically what I'm trying to say, the place where you can store the data. So what is the difference between a data lake and a data warehouse? I think I answered the question in the last session, but just to make it more clarity, a data lake is nothing but, okay, a data lake is nothing but you have raw data from all different sources. So when I say raw data, there's no specific purpose. Okay, there's no specific purpose. So I'm trying to build a model. The model is supposed to predict, okay? So the model is supposed to predict when the customer is going to churn, okay? And why they are churning. Who's going to churn? Okay, I want to predict, run a predictive model. Who's going to churn, when they're going to churn, and also the reason for the churn. So these are my three prediction. Okay, so in this context, I need invoice information, billing information, pricing information, customer feedback, and also customer service calls. Okay, so these are the data we need. So this is basically not discussing about in each of this what field I need. I'm going to get, let's assume customer table has 100 fields. Okay, customer table has 100 fields. Invoice table has a 200 fields. Billing table has a 300 fields. Okay, customer call has 500 fields. Okay, and customer feedback is basically a preform text. In data lake, you see all the table, all the column. In data warehouse, you don't see all the table, all the columns. Okay, so let's say in data warehouse also you have all the table, you have an invoice, you have a billing, you have a pricing, you have a service, and you also have customer feedback. In a data warehouse, what you see, you don't see all the fields. All right. In invoice, what are the key information I need? Because the data warehouse is meant for a specific purpose. It's just reporting. Okay, it's just for reporting. Data lake, it's not meant for just only reporting. Data lake could be for anything. It's like a lake of water. It could be used for many purposes. It could be used for drinking. It could be used for cleaning. It could be used for agricultural. So that is what it is. But if you take data warehouse, it's like a well, okay? It's like a well. So what you do, you just only use for drinking purpose. So you cannot take what you have in a well and use for an agriculture purpose, correct? So you may not be able to use, correct? So like this, the difference between a data lake and data warehouse. So when you go to data warehouse, you will see limited set of field with a limited set of data. But when you go to data lake, you will have all the field, you will have all the data. Why? You don't know how you are going to use this one. Okay, at the time of bringing this into data lake, you don't know how you are going to use all of them. So it could be today, it could be tomorrow. So you have to have a single place where you can get all the things what you need. Okay, all the things what you need. Typically a data warehouse, okay, typically, I'm not saying always, typically a data warehouse deals with the structured data. So that means data stored in a table or a column, you can process and retrieve this one. When you go for data lake, it could be anything. So what we talked at the beginning, so data could be in any form. In what form? It could be structured, it could be unstructured, it could be semi-structured, it could be videos or image, voices. So a data lake will have all this type of data. Okay, data lake will have all this type of data. So in summary, what I'm trying to say, when we say data lake is basically from where the machine learning models will take data. Typically, I'm not saying always, typically the machine learning models will take data from a data lake and process this further. Okay, a machine learning model will take data from a data lake and run the model on top of it. So what kind of data it can take? The training data comes from data lake. The test data comes from a data lake. Okay, so the training data and test data comes from a data lake, and also your production data. When I say production data, so the real customer on which you want to run the churn model, okay, that is also coming from the data lake. So most cases that I am involved, we always have data lake. We never go to data warehouse to get the data. So the key difference between data warehouse and a data lake, in a data warehouse, you have a data with a specific purpose. When I say specific purpose, I'm going to create an invoice report. I'm going to create a billing report. I'm going to create XYZ report. So in that context, it has only that specific information or the requirement what we have. In the invoice, these are the things I want to see. I want to see invoice date. I want to see items order. I want to see unit price. I want to see order date. I also want to see any discount if it's applied. That's it. I don't care anything. But there are other information in the invoice. So if you are going to look at that and bring everything for a not a specific purpose, it could be current or future. That is data lake. Okay, the data lake will not have a limited field. It will have all the fields, but a data can be many fields. Okay, 1 second. Can you make video on my video is not working, sir? Okay, my video is not working. I can make that one. It's not a problem. I can do that. Let me make that one. Give me 1 minute. I'm doing this right now. Can you see? Can you see the camera?
No, sir.
Yeah, it's not working actually. So that's what I told in the beginning. Anyway, so let's move on. So what is the data lake? As we talked about it. Okay, 1 second. I'm going to minimize this one. Sorry. So the data lake is basically has all the data that is required for current and future needs. It doesn't have to be in a specific format. It could be any format. It could be in a structure, unstructured, semi-structured, image, videos, voice, and etc. And a data lake supplies data for all purpose. Okay, all purpose. So what is that all purpose means? Today I'm just predicting the customer who's going to churn. Tomorrow I'm going to predict when the churn is going to occur. And day after tomorrow I'm going to predict the reason for the churn. Correct? You see the expectation, number one, when the churn is going, sorry, who's going to churn, when the churn is going to occur, and why it is occurring. So it keep increases. When it increases, I don't want to go back and get the data again and again and again. I want to have one single centralized place for anything what I'm going to do. And that is basically data lake. Data warehouse, it has a very defined set of focus. Okay, so I'm going to have data which is going to be used only for a specific purpose. In this case, who's the customer going to churn out? So when you're going to run a predictive model for when the churn is going to occur, for that, you don't have the data in data warehouse. You have to go and get it. Not only when and why it is happening. For that also, you don't have a data warehouse. You don't have data in the data warehouse where you can run that model. But if you look at data lake, it has data for anything, everything, what you want to do. That's the idea behind. Move on. So how does a data lake typically look? I'm not saying this is how it's going to be. Typically, it's going to look like this. So it has a connection to the backend systems. So it could connect to SAP, Oracle, Microsoft, IBM, video, sensor, etc. and pulls everything, keeps in a single centralized place. Okay, it could be one single centralized place. It could be multiple single centralized place. So it is going to keep it in a one single centralized place. Then it supplies to different enterprise users. So it could be human resource, it could be sales and marketing, it could be finance, it could be supply chain, it could be IT. So everybody can come and get the data what they need. Okay. So the point is, it's a centralized data platform, stores enterprise data and supplies data across the enterprise, regardless of function, location, time, and frequency. It doesn't matter where you are. Okay, whether you are working from Asia Pacific or Europe or Middle East, it doesn't matter where you are. Okay, so it goes across the board and it basically provides the data. So that's the kind of architecture behind this thing. Okay, so what I want you to find out, what's the difference between data warehouse and data lake, other than the points what I told you. To develop an AI-based application, which one we need, data lake or data warehouse? Okay, so if you are going to build an AI application, what do we need? Do we need data warehouse or data lake? Okay, I'm sure you all know the answers, but think about it and go further. Okay, keep in mind, okay, what is really important? Okay, what is really important? These areas, working with structured data, okay, that you already know, no question. But if we teach students, how do we connect to Twitter and read the data? That is quite challenging. And how to connect an Apple Watch and read the data. The student, you don't need a lab for this one. Okay, you can use Apache Kafka. Apache Kafka is an open source. Watch, okay, I'm sure most of the students has either Apple Watch or some kind of a watch. Okay, so you can connect and read them. Okay, or most of the laptop comes with the camera, except mine. So you can easily connect to the camera in the laptop, okay, and read the image. So those are the exercise students can do, simple things, correct? So that is working with the machine data. Okay, sensor. If the school college has any sensor, how do we connect this one? So that would be very helpful for the student to understand. And also how to work with the in-memory data. I talked about Alexio. Correct? Alexio is an open source. Alexio is an open source. So student can download and install and work on Alexio. Alexio also is one of the good tools to work on, correct? So anyway, I'm just trying to tell you, okay, I'm trying to tell you that. So if you start working on these things, would really help you a lot, correct? So how do we basically build something like reading sensor data, reading device level information, and storing and processing this one? That would still help a student a lot. So from that point of view, basically what student need to understand. All right. The next one, what it is, typically what I've seen. Okay. Typically what I've seen. So the students would also need to understand how do we model these data sets? Okay. How do we model these data sets? So once the model predicts and writes something, you have to expose this to the users. You have to expose to the users. So how do we expose to the users? There are two forms. Either you can expose in the form of an Excel spreadsheet, or you can write in a table, or you can create some kind of a multi-dimensional data model, correct? So based on what the end product is going to look like. If the end product is going to look like, the students, the users wanted to look at the prediction, that's about it, correct? So in my case, when I predict the customer who's going to churn, I also have to justify, correct? I also have to justify what features I used and what is the weightage of each features. Okay, so let's say I use 10 features, okay, to predict the customer. Okay, to predict the customer churn, I'm using billing information, I'm using invoice information, I'm using the pricing information, I'm using service calls, I'm using customer feedback, etc. Let's take these five. Okay, billing, invoice, pricing, customer call, and feedback. So these fives, out of these fives, which one is the influencing factor for John to churn out? Okay, so that may not be same for all customers. Okay, that may not be same for all customers. Okay, so that model outcome, which is basically the influencing factor for someone to churn out, where do I store? You can write in a file, or you can write in a table, or you can write in a cube, however way you want to write. But that is driven based on what is the next level of analysis. In my case, so based on the customer churn, what they want to do, they want to look for sales declining. So if I'm going to churn out this much, how sales I'm going to lose? All right, if my sales goes down, and what is the revenue impact for me? So I want to analyze this one. In order to analyze this, you have to store the data. In what form you can store? Option A, you can use simple table. Option B, you can store something like this, a multi-dimensional model. It's much easier to work. Keep in mind, these are all virtual. It is not a physical. Okay, it is not a physical. Keep in mind, it is not a physical. So you don't have to physically store data, because this is for analyzing. So this is for analyzing. So this is what the model pipeline does. The model pipeline it makes the end-to-end process work together. Okay, so the student perspective, or when you want to teach something like this, two things you have to keep in mind. What you need to keep in mind, when a model predicts, such as the predicted outcome, whether the customer is going to churn yes or no, yes. So in order for a customer to churn out, what is the key influencing factor? To store all of this, along with the probability, along with the confidence level, you need a place to store. So that place could be a table, that place could be a cube, that place could be a file. So if it is a table or a cube, how do you model that? That's the point I'm making. So why do you need this one? And this is where the end user will go and look for. So what does it look for? In my case, if a customer is going to churn out due to a service quality call, so that means the customer is not happy. So the customer called customer service. There is no response, but they're not giving a proper direction. The customer decided to churn out. Option B, the customer is going to churn out because the pricing increase. So in both the cases, what the business will do, they will try to contact the customer. Okay, why? Hey, I know you're not happy because your billing went up. Let me do something for you. I'll give you 10% discount. Okay, all right. The customer might stay with you. So let's say the customer is not happy because the call quality went wrong. Okay, there was no enough proper discussion that took place in the call. So the customer got pissed off. The customer wanted to leave. So in that case, what they will do, the sales rep, they will call and tell, hey, listen, I know you're not happy. I'm going to give you 1 month free. Okay. So I'm not going to charge you anything for this month that you're not happy. Okay. So how about that? So then the customer is not going to churn out. So they basically wanted to go back to the customer and try to avoid try to stop the prevention that happens, correct? So for that, they need the predicted outcome along with other information so that they take corrective action. So for that, where do we store the data? These are the things you can do. All right. So this is basically at a high level what I covered. Okay. There's a lot more involved. Okay. A lot more involved. So what I did, I just kind of outlined the boundary, what you need to know in order for you to teach data engineering. Okay. Data engineering. So I'm just going back to the topic, what I listed here. So out of all the topic, what I feel is really critical, distributed data processing. Okay, so that is something that working with Spark or working with Flume, Apache Spark, Apache Flume. So those are the technologies. But as a concept, you need to understand what is distributed data processing, how it works. Second, how do you work with in-memory? Okay? So that, like I said, we don't have to physically store data. We can retain in memory, run the model, and get the model outcome. You store the model outcome, or create a report, print the report, done with that. You don't have to really store the model outcome. Okay? So second, we need to understand how to work with in-memory data sets. Real time. Like for example, when you type something on your cell phone, things happen at the moment. Okay? How you work with real-time data. Okay? How do you work with the real-time data? And next is working with various data sets, text, semi-structure, structure, video. How do you work all of them together? Okay, how do you work all of them together? The next is the machine level, sensor level information. So I feel these are all really critical area. And this is basically what makes this whole process difficult. If you just teach about working within a simple Excel file or a table, it's not going to fly. Okay, it is not going to fly. So at least the students should have thinking power to take all these things, connect and run this model. Because like, take an example. I want to train the model on image. The same model also need to understand customer demographic. So now I have two set of information. One is a structured data. Second is images. How do we train the same model with these two? Okay, is it possible? Yes, it is possible. So model need to learn about the customer demographic that is in the table. The model also need to understand a customer's image. Basically, when a customer walk into the retail store, it has to capture the face and detect the face and know who this person is. So this is John. So now I need to go and get John's demographic information. So in that case, whatever model I choose, that model will perform facial detection. That model also will perform the retrieval of demographic information. Okay, so that means it needs to be trained both the text as well as images. Correct? So it is quite possible. It is quite possible. So we have to know. We should know how do you work with all the things. So I would call this is the framework. So this framework is not okay easy to learn. It requires a lot of effort, a lot of things. So if you could put this part of your curriculum or teach the students, it will be very beneficial. If you look at across the board, okay, I know there is so many training institutes in India and across places. Okay, so I'm not convinced there is any one training institute who's providing quality education on data engineering. Okay, who's providing quality engineering on data engineering, quality education on data engineering. Correct? So why? It is very difficult. It is not an easy subject to teach. It is not an easy subject to teach. It's very difficult. But the need for the need for data engineering is huge and very high. Okay, very high. The only reason artificial intelligence become live right now are this much hype. One is technology. Second, data availability, and that is what made artificial intelligence go to the next level. As a concept, artificial intelligence been around for several years. Okay, so now it become a reality because two reasons. One is there is a technology readily available. Second, the amount of data that is required for build applications is there. Okay, those are the two reasons. So if you could manage to teach this one, that would be awesome. That would be awesome. All right, I'm ready to take any questions. If you have any questions, please ask me. Okay, if you have any questions, please ask me. Any questions? Do you have any questions? No questions? Interesting. Interesting. All right. So I had requested Dr. Abhilash to conduct test. So he will be sending out questions to you. I already given to him. Okay.
Yes,
So
sir.
that has, yes, sir.
I will conduct, sir. No problem.
Yeah. So that has 3 sets: easy, medium, and I wouldn't say complex, somewhere around that. Okay. So he's going to conduct the test probably tomorrow. And based on that, we will see. All right. If you don't have any question, I'm good. We will stop here. But as a closing remark, data engineering, it's the most challenging, difficult things to learn. And that is why you don't find too many or no institution teaching data engineering. Okay. But there is so many institution out there teaches machine learning, teaches artificial intelligence, deep learning, and etc. But if you look at what they're teaching, very basic. Okay. Very basic. That may not fly in the real world applications. From the real world application point of view, it is absolutely critical to know in some capacity working with very, very large complex data sets, which falls under data engineering. Okay. I would encourage, please learn, spend more time, understand. Sky is the limit. Okay. Sky is the limit. There's a huge potential there. Okay. There's a huge potential there. Thank you so much. I wish you all the best. Good luck. I'll talk to you tomorrow with the deep learning concepts and a demo. Take care. Thank you. Bye.
Yeah, very good afternoon to all. As per schedule, today Jyotish was given about data model. tomorrow again tomorrow one case study is there on COVID by using of deep learning. How can you assess? How can you identify the COVID? Tomorrow one interesting session is there from software industry. Tomorrow schedule is tomorrow we are going to conduct exam, and very important thing is attending of all the sessions and clearing of the exam is a minimum criteria for getting certificate. So once again, I request you all attending of all sessions. For every session, we are forwarding the feedback. Your feedback only considered as a attendance. All these 6 days on all the sessions attendance, all the sessions your feedback will be considered as an attendance. For getting of certificate, you have to attend all the sessions and you have to clear the exam what we are going to conduct tomorrow. So participants, I'm requesting you participants, any issues regarding registration ID, those who are continuously attending all the sessions, those only are getting IDs. If you miss any feedback form, that's why somebody is not received any ID. So even whatever, I give an ID upon your request. Still any issues, please.